This is for the Unit 4 review. So, questions like these. We're looking at, we've got these angles, and we have to remember that the shortest side is always across from the smallest angle. So, angle C is our smallest angle. So, we've got sides AB, BC, and AC. Well, across from C would be AB because it's the only side that doesn't have a C. So there's our shortest side. And if you want a visual, A, B, C, across from it is AB. So let's take a look at another one. We've got A, B, and C. So angle A is our smallest at 20. So we're looking for the one that doesn't have an A. Well, AB, AC, so it's BC. Okay. Now, the two sides of a triangle are 22 and 33. Which inequality represents the third side? Now, for this, you can't have negative sides. Well, that's a negative. So goodbye. We're certainly not going to use 22 and 33. So goodbye. So that means it's choice A. Now, what's actually happening here is we do 33 plus 22, and we get 55. And we do 33 minus 22, and we get 11. And so that means the third side is somewhere between 11 and 55. Because remember, the three sides of a triangle, two of them have to add and be bigger than the third side. So if I did 11 plus 22, I'd get 33. Well, 33 is not bigger than 33. But if I did 12 plus 22, I'd get 34, which is bigger than 33. If I did 55, well, then the two small sides would be 22 and 33. And that is 55. 55 is not bigger than 55. But if I choose 54, well, 55 is bigger than 54. So that's why it's somewhere in between. And so it's choice A. And so if I've got 1 and 4, well, it's not going to be any of those ones that say 1 and 4, and it's not going to be the negative, so it's choice A. 4 plus 1 is 5. 4 minus 1 is 3, so 3 and 5. Okay, sorry, I had it paused for a while. So, for this one, they give us this angle, and of course, let me pause again. Okay, let's try again. So, this angle is 133. They tell us that this angle, CAD, is 43, and that BCD is 58. So basically, we need X to find Y. Well, to find X, we do 133 minus 58. So that's 12, and so 575. And now that's an exterior angle for this. So 75 minus 43, and so 32. So basically, we subtract all three numbers. And this is the same thing, so it's just another practice question. So we do 132 minus 53, and then we subtract 33, and so 46. Okay, now we can make this incredibly complicated and find this angle, and then do the properties of a triangle to find this angle, and then find this angle, and then properties of the... Why? Just subtract them all. All right. Now, this one is admittedly a little more complicated. Okay. I'm getting tired of all these messages. Okay. So, in order to do this, we need to know this angle and this angle. Well, so we got to find x, we got to find y. Now, this is an exterior, this angle here is an exterior angle to this triangle. Which means, so that means that x plus 76 equals 139. So x is equal to 139 minus 76. Now, these angles make a linear pair, so that means y plus 139 equals 180, or y equals 180 minus 139. And then this all is supplementary, and so that means that w plus 45 plus x plus y equals 180. Or w equals 180 minus x minus y minus 45. So we simplify. 139 minus 76 is 363. 180 minus 139. I had trouble talking today. Is 41. And so then we plug in here. So w is 180 minus 63 minus 41 minus 45. Well, you do all the subtraction, and that's 180 minus, well, 63, 41, and 45. Well, that's 8, 9. That's 10, 14. So minus 149. And so 131. And so it's A. Okay, same situation. Different numbers, same situation. So we find x, we find y. So y is 180 minus 149, and so y is 31. X equals 149 minus 104, and so x equals 45. And so 63 plus 31 plus 45 That's 8, 9, 139. And so W equals 180 minus 139. Well, that's 1 and 41. Okay. Nice, simple, to the point. Find that one. Find that one in order to find that one. Okay. Now, this is the one that gives people a lot of trouble. It's not that difficult, but everybody makes it hard. Okay? Draw a sketch. It doesn't have to be perfect. It's just got to be a sketch. So this is the point, -5, 1. Now, our other point is at -1 something. So this is the line x equals -1. Now, how far is it from this point to here? Well, from -5 to -1 is a distance of 4. Now, they tell us that the distance from this point to our other point is 5. So it's either going to be that way 5 or this way 5. Well, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Well, we've got b and c right there. So there's 4 squared plus equals 5 squared. And we're just looking for a. And so we've got a squared plus 16 equals 25. Subtract 16. A squared is 9. Square root. A is 3. So a is 3. Now remember, this y value was 1. So we're looking for y. So if this was 1 on the y-axis, we go up 3 and down 3. So plus 3 minus 3. Well, 3 plus 1. I did that backwards. Let's fix that. 1 plus 3 is 4. 1 minus 3 is -2. Helps if I use the right question. So 4 and -2. Now, let's try that again with these points, as I cross out the point instead of actually underlining it. Okay. So 6, -3. And we've got at -6y. Well, again, from here to here, this time it's going to be 12. They tell us the distance is 13. So that's a squared plus 12 squared equals 13 squared. So a squared plus 144 equals 169. And so a squared equals 25. Square root, and a is 5. So that means we went up and down 5. Our original value was negative 3. So we do negative 3 plus 5, negative 3 minus 5. Negative 3 plus 5 is 2. Negative 3 minus 5 is negative 8. So 2 and negative 8 is choice A. Okay. Now, for this question, this does not have to be done on a graph, so you don't have to do it this way. I am going to show it to you this way, but you don't have to do it this way. You could use the distance formula, which is d, and it's on your formula sheet. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, and just plug in x1, y1, and everything and see what you get. And do that for AB, BC, and AC. Okay, you want to do all three sides. Or you can do this on the graph. So on the graph, we sketch it out at 2, 0, negative 6, 3, 4, 5, 6, 1, 2, 3, 4, and 0, 6, 1, 2, 3. So that's C, B, A. See, can't draw a straight line. Okay, now for AB, gonna make this little right triangle. Well, to get from here to here, well, that's 2 and 6 more, so that's a distance of 8. To get from there to there, that's 4. So for AB, I'm doing this part with the Pythagorean theorem. So that's 8 squared plus 4 squared. And so that's 64 plus 16. And so that's square root of 80. Now, I can figure out what the square root of 80 is, or I can leave it like that. Since I'm just checking to see if they're equal or not, I'm going to leave it like that. And now I'm going to do BC. Well, for BC, I go up 2 and over 6. So 2 squared plus 6 squared. And so that's 4 plus 36, which is 40. And now I'm going to do AC. Did not mean to press that button. Definitely didn't mean to do that. I need to bring that back. I hit delete. So I go over 1, 2, and I go down 6. And so that's 2 squared plus 6 squared. And so that's 4 plus 36, which is 40. Well, these are the same. So AC and BC are equal. And so apparently I made a little typo somewhere. Either that or I made a really big mistake. 6, 2, that's 4, Let me hit pause while I check. Alright, so
I stare at computers. There's two of us.
yep. Okay, so there is a typo on this question, and I apologize. It should be BC is AC, and since this is the closest one to that, I'm going to choose this one. And I will fix it on the review. And so I'll talk to her when she gets out, because I can't exactly go in there. And so I will fix that on the review before the end of the day, so that when you're doing this, it will be right, so that you can choose the right answers when you're studying. Okay.
You're talking to me, but I know you're not talking to me.
Yep. And so now for this second one, it's the same idea. We sketch it out. So 2, -2, 8, -2.
Hopefully this year we don't have to print extra pages for your test.
That would be a great thing. And 4, -8. And just like before, we make our right triangles. So from A to B, can't really make a right triangle since it's a straight line, so we just count the distance. 1, 2, 3, 4, 5, 6. So AB is easy. AB is 6. So we move on to BC.
Has anybody ever tried to record you when you sit out here and do that?
Nope.
Okay.
Adrena, come here for a second. Alright, so for BC, if my pen will break, there we go. So we count down. 1, 2, 3, 4, 5, 6. And we go over 1, 2, 3, 4. And so that's 4 squared plus 6 squared.
Yeah, I didn't sign up to learn math.
16
here, by the way.
plus 36. And so that would be 4652. And so now we go and we do the same thing with AC. Well, from A to C is over 2, but it's going down the same amount as B, so that would be 6.
Pleading difficult with who because there's no one in here.
And so AC is 2 squared plus 6 squared. And so 4 plus 36, which is 40. Well, 6 is not the same as radical 40. Square root of 52 is not the same as square root of 40, so since none of them are the same, that's choice D. It's scalene because they're all different.
What'd you do, baby? Oh, I learned geometry.
Okay. Now, this is Pythagorean theorem. And I know we've kind of already been doing it, but hold on a second. But in this case, you know, it's already half done for us. They already told us the areas, and so we just got to find the length of this side. Okay, so we just have to do 169 minus 144, and then take the square root. In this case, 5. And so over here, it's the same idea. We got that area and that area. So we subtract 100 minus 64, and we get 36. Take the square root, and it's 6. And that's all there is to it. You guys are trying to make these things more difficult than they are. And it's just subtract and take the square root. Now, for questions like this, we've got to use our angle, side, and whatnot. But again, it's not too hard to do this just by using some process of elimination. Okay? They give us a pair of sides. So since we have two sets of sides, we can get rid of the angle, side, angle choice. So now we got two choices that say side, angle, side. Well, A, B, C. That's A, B, C. So it goes from the corner that has the two dashes to the corner, the opposite corner, and then down the one dash side. So that means we start at E, go across to D, and then down there. So that's the way it has to match up. So ABC has to go EDC, so that way all the letters match up. ABC, EDC, ABC, DEC, that doesn't match, so it has to be A. How you doing? You passing? Okay. Alright, so now for this one, same idea. We've got two angles that are going to set up. So that means we're definitely not going to go with the two sides or the three sides. So that leaves us with just angle, side, angle, because we have the side in between that makes it work. Alright, so. Oh, working hard. Making videos. So we check this one, and so just like before, we've got an angle, we've got a side, and so we can't show, we have no way of showing that this is the same as that, so we look at these vertical angles. So we got angle, side, angle. So we can get rid of these side angle, side ones. So it's a matter of ABC, is it DEC or DCE? Well, ABC goes that way, so DEC is what we want. So that means it's choice B. Then over here, we've got side, angle, and then this is part of both, so side, angle, side. So goodbye to these two. And again, ABC, so that means we want AEC. And so choice A. And now this is our final question, the proof. Now you can do this as a two-column proof or a flowchart proof. So I don't care which type of proof you do, as long as you do your proof. So first thing, write your givens. So I'm going to do this as a flowchart proof, assuming that my givens. So AB congruent to AD, and that's given. How do I know it's given? Because it told me given. Then angle BAC congruent to angle DAC, because it's given. Now we actually have to do a little thinking. So we know this angle and this angle, we know that. Well, this side is part of both triangles. So we can say that it's congruent to itself. So AC congruent to, how you doing, Trouble? AC. And anything that's congruent to itself is the reflexive property. we got a side, an angle, and a side. So we can say the triangles are congruent. So triangle BAC is congruent to triangle DAC. And that's side angle side. Well, now that we've shown the triangles are congruent, we can finally say that those angles are congruent. Yeah, you're good. And so angle BCA is congruent to angle DCA, and that's by CPCTC. Corresponding parts of congruent triangles are congruent, which is a mouthful, which is why we just use the first letter of each word. And that's the entire proof. All done. There you go. Make sure to study for your test so that you pass it. If you have questions, send me a message on Teams so that I can help you out. Good luck.